This is our plate tectonics review key. So our first problems are over vocab. So number one, Pangea is letter C. It is the supercontinent that formed about 300 million years ago. Number two, lithosphere is letter E. It is the layer that forms the thin outer shell of the earth. Number three, Rift Valley is letter B. It is the valley at the center of a divergent boundary. Number four, seafloor spreading is letter D, the process by which new seafloor forms. Number five, mid-ocean ridge is letter G, which is an undersea mountain range. Number six, subduction zone is letter A, a region along a plate boundary where one plate moves under another. Number seven, continental drift is letter H. It is the hypothesis that continents once formed a single landmass. And then number eight, convection currents is letter F. It is the cycle in which heated material rises and cooler material sinks. Number nine, the four pieces of evidence that Wegener used. So these are really important to make sure we know, understand, and can talk about. Okay, so number one is that the continents fit together like puzzle pieces. Number two is that matching fossils are found where continents fit together. Number three is that landforms also match up where continents fit together. And number four is that glacier evidence was found in areas that today would not be a location where glaciers are formed. Okay, so again, like I said, those four pieces of information are very important. Make sure you know, understand, and can talk about those. So number 10, our three types of boundaries are transform, convergent, and it should be divergent. I'll change the last one to divergent. Okay, so our first part says to draw a picture. So for transform, our picture is that they just slide past each other. Okay, and a description of what is happening and evidence of the change. Okay, so description of what is happening are two plates slide past each other. And our evidence for this one are earthquakes and faults. Okay, just like the last question, this question is also extremely important that you're able to do and talk about these descriptions and how we know that these boundaries actually exist. And our evidence, earthquakes and faults, help prove that these transform boundaries exist. For convergent, we just have two arrows pointing towards each other. Okay, so our description is two plates moving towards each other. And the evidence that shows that this is actually happening includes mountains. And this is continental and continental colliding. Okay. Then we have volcanoes and islands. Okay. And these can happen for continental and oceanic, or oceanic and oceanic. So this one's continental and oceanic, and this is two oceanics. And then divergent, we should have arrows that move apart. Okay, so what is happening is two plates moving away from each other. And evidence that this is happening is that it forms rift valleys on land, and it forms mid-ocean ridges in the ocean. Okay, and this is also the type of boundary where new crust is formed. Okay, so again, these past two questions are extremely important that you guys are able to explain and talk about both Wegener's evidence and our types of boundaries. Okay, Earth's mantle is heated by convection currents in the mantle. Okay, number 12, I know it says list of 3 main layers, but obviously we're doing 4. And it says from the outside in. Okay, so we're going to start on the outside. We have our crust, mantle, outer core, and inner core. The 2 layers of Earth's core, we just said were outer core and inner. What is special about the outer core? The outer core is liquid. If I were to ask what is special about the inner core, it is solid because of the extreme pressure it is under. Number 16, well, I just answered that. So it is solid rock because of the great amount of pressure. Number 17, what deep ocean feature forms at a subduction zone? And that's a trench or a deep ocean trench. Number 18, what forms when 2 plates made of continental lithosphere collide? And we get mountains. A sudden movement along a boundary of a tectonic plate is called an earthquake. How do volcanoes help identify locations of plate boundaries? Okay, so volcanoes are where 2 plates collide. What theory explains why and how continents move, and that is plate tectonics. Remember, the theory of continental drift does not explain how they move, it just provides us with some evidence to help prove that they are moving. And the last one says explain how the theory of plate tectonics helps support the theory of continental drift. So this one's kind of long, guys. So I'm going to write it all down and then read it. So if you need to fast forward through this point where I'm writing it, that is just fine. Okay, guys, so this is really important here. So I say the plates are moved around on Earth's surface due to convection currents in the mantle. Seafloor spreading is where a new crust is created at a divergent boundary. This movement that we have creates our three boundaries: convergent, divergent, and transform. At convergent boundaries, we see mountains and volcanoes, which are continually growing. At divergent, we see rift valleys and deep ocean trenches that have magma coming up and push out older rock. At transform, we have earthquakes from plates quickly moving, which relieve or due to relieving built-up pressure. Okay, so all of this shows or helps prove that our continents are actually moving. Okay, so we have places that are moving apart, places that are coming together, places that are sliding past each other, and even though this happens very slowly, we still have evidence that this has been happening over time.